Welcome to What's Up in the Sky in October 2025 with me, Lead Night Sky Ranger Jeff. This month we look at Jupiter, which finally rises before midnight, take a look at a couple of on-the-horizon lunar craters, and begin to explore an interstellar visitor. Mercury and Mars reach conjunction on the 19th, but very low in the sky at only 4 degrees. You'll need an excellent southwest view, but if you have it, Mercury will be easy to spot, shining at magnitude -0.2 just 20 minutes after sunset. Mercury reaches greatest elongation from the Sun on the 29th when it is 24 degrees from the Sun, but again too low for most observers. The completely clouded Venus rises at 0500 on the 1st and 0600 on the 31st, shining at magnitude -3.9. It is 91% lit on the 1st and 96% on the 31st. The Moon provides an early-in-the-month viewing of 2 craters, J. Herschel and Philolaus, in the north-northwest of the Moon just at the horizon. J. Herschel is 96 miles in diameter. It's an ancient crater whose walls have been repeatedly pummeled by new impacts. Notice, if you can, the rubble around where the rebound should be, the rubble caused by the huge impact that created the Imbrium crater. Next, move on towards the Moon's north pole and spot Philolaus. You will notice that the crater walls are intact, showing it to be a much younger impact. Return on the next couple of nights and notice the changing shadows. J. Herschel is named after John Herschel, who charted the southern sky, while Philolaus was a 5th century Greek who concluded, like Pythagoras, that the Earth was moving and not stationary. Mars is heading for conjunction with the Sun, but it is still safe to view with a comfortable 25 degrees of separation between it and the Sun. Like Mercury, it is low on the horizon, and each day it progressively gets lower and closer to the Sun. Shining at magnitude 1.5, you will have to wait for darker skies than for Mercury to view it. It is, however, really too small to see any detail, being slightly less than 4 arcseconds in diameter. Ceres is our asteroid of the month, as it is at opposition. You will find it in Cetus the Whale, in the southeastern sky, well below and east of Saturn. It rises about 1945 on the 1st, and it is already up in the sky on the 31st. Consult the Minor Planet Center for exact locations. Its diminutive size of 0.66 arcseconds and dimness of magnitude 7.65 make it a small telescopic object. If photographing it, take images about 1 hour apart to note the object moved in relation to the background stars. If you are visually observing or sketching, it's recommended that you sketch it at least a day apart to determine which object moved. Jupiter rises at 0030 at magnitude -2.1. By dawn, it is 50 degrees high. By the end of the month, it rises at 2236. Take your time observing Jupiter. You will probably notice the focus changing as our atmosphere roils with rising heat into the upper atmosphere. Wait for those moments of super sharp view and be amazed at what you can discern. There are several transits of the Galilean moons. Io and Europa overlap during their transits, a rather rare event. Look for the timing in the calendar of events. Saturn is the best object in the early evening sky to view. Its rings are still gradually closing to edge on, going from 1.5 degrees to a scant 0.6. For us, this means they will be virtually edge on. In fact, they may be so narrow that you might not even spot them in small telescopes without sufficient magnification. Glowing at magnitude 0.6 at the beginning, it will dim to 0.8 by the end of the month. The planet itself is at 19 arcseconds, just past its opposition last month. There are 2 transits of Titan, its largest moon, on the 5th and 21st. I will put the times in the calendar of events. Look for Tethys, Dione, and Rhea, the 3 smaller and dimmer moons at 10th magnitude. With the rings virtually edge-on, now is the time to spot Enceladus at 12th magnitude. Without the rings' brilliance, you might just be able to spot them. Theoretically, an 8-inch telescope should be able to capture it. Uranus rises at about 2100 on the 1st and 1900 on the 31st. At magnitude 5.6, it is viewable with the naked eye in dark skies, but in our area you'll need binoculars or a small telescope. Beware though, as with all night sky objects, that when low to the horizon, the atmosphere can not only distort its apparent position, but also can greatly affect its apparent magnitude. For instance, when just on the horizon, its magnitude is reduced by a whopping 22, whereas once it is up at about 20 degrees altitude, that changes to just 2.6. Neptune is about 3 degrees from Saturn, and since it was in opposition last month, it is up in the sky all night long. At magnitude 7.7, it's just a tiny bit brighter than normal, but still only spans a mere 2 arc seconds. Still, it's always a great catch to add to your collection of seen planets. The Orionid meteor shower occurs from the 2nd to November 7th, peaking on the morning of the 21st with a maximum of 20 meteors per hour. This year should be better than most, with a new moon occurring on that date. Comet 2025 A6 Lemon visits the inner solar system for about 2 months. It will rocket into an area about 47 million miles, about a half astronomical unit, from the Sun, brightening to magnitude 8 before just as rapidly leaving. Start looking for it mid-month. Look for it between the 13th and 23rd as it crosses Canis Venatici, Bootes, and the Serpens Caput, passing near M94, M3, and Arcturus. You can find Arcturus by tracing an arc from the handle of the Big Dipper. It's the bright star that stands out. For photographers, change your exposure times to 25 seconds, otherwise you will get blurring as this comet streaks by. Constellation of the month is Equus, the Horsehead. This tiny constellation is nestled between Pegasus to the east, Aquarius to the south, Aquila to the west, and Dauphinus to the north. There are no non-star objects in Equus. Our object of the month, therefore, is M15, the Pegasus cluster. It is about 35,700 light years from us with a magnitude of 6.2. It contains some 100,000 stars within about an 88 light year area, making it one of the most densely packed clusters. It is estimated to be 12 billion years old and was discovered by Jean-Dominique Maraldi in 1746. Charles Messier included it in his list of non-comet objects. Our question of the month is, if we scooped a typical 3.5-gallon bucket of space, what would it contain? 4 million neutrinos, 13,000 hydrogen and helium atoms. Maybe we would have a 1 in 77 chance of a dust particle. There would also be photons of light, and surely there would be virtual particles popping into and out of existence. We'd never see them, of course, because they appear in pairs and instantly annihilate themselves. Here is your orrery. Here is the calendar of events. The list of music I've used. Okay, I admit I forgot last month's dad joke, so you get 2 groaners this month for the price of 1. Why are people who study the moon optimists? Because they always look at the bright side. And what kind of books do romantic aliens like to read? Starries. Okay, I want to make an addendum to my usual presentation here. One of the questions has been arising is 3I Atlas, which is an interstellar object, which is a comet that is transiting through our solar system at the remarkable speed of about 130,000 miles per hour. It will reach perihelion on October 29th, 2025, and be just inside of Mars's orbit at that time. Its closest approach to Earth will occur in December of 2025 at about 1.6 AUs, or 150 million miles. It won't pose any sort of a threat to us. I'm quoting now from High Point Scientific, quote, "The comet's hyperbolic orbit with an eccentricity of 6.11 is the highest recorded among interstellar objects, surpassing 1 Oumuamua, which was a 1.2, and 2I Borisov, which was a 3.4, ensuring it will exit the solar system after its brief visit. The interstellar visitor offers a rare opportunity to study material from another star system, potentially carrying clues about the formation of distant planetary systems. Unlike solar system comets, which originate from the Kuiper Belt or the Oort cloud, 3I Atlas formed around another star and was ejected into interstellar space millions or billions of years ago. Its high speed and open trajectory mean it will not return, making current observations critical. The comet will remain visible to ground-based telescopes through September 2025 before coming too close to the Sun to observe, and is expected to reappear for study in early December 2025. One thing I want to note is that it's going to be at its brightest about a magnitude 11.5, which means that essentially at this point in time you'll need a telescope of at least 10 inches in diameter to view it. October is a great time to observe the night sky. Dress for warmth and beware that most nights will be humid with dew. Enjoy the night sky.